Okay, let's start. Alexa makes regular end of term deposits into her RRSP, which stands for Registered Retirement Savings Plan. That will be converted into an RRIF, a Registered Retirement Income Fund, 28 years from now. During retirement, Alexa would like to receive $3,600 at the end of every 6 months for 22 years. If interest is 4.07% compounded semi-annually for both the RRSP and RRIF, answer the following questions and round all answers to 2 decimal places where necessary. All right, so the first question is, how much money should Alexa have in her RRIF to receive payment of $3,600 at the end of every 6 months? Okay, so let's come over here and have a look at what is happening. So we have 2 parts to the question. One is the RRSP, all right, and the other one is the RRIF. All right, so we'll see what each one has in terms of the information that is required to make it all work. Okay, so let's go. All right, if we go to the RRSP, it says it will be converted to an RRIF 28 years from now. So we know that this will run for 28 years. All right, so that's the savings. Okay. Now, during retirement, Alexa would like to receive $3,600 at the end of every 6 months. Okay, so here means Alexa will receive money, which is really a payment. So a payment of $3,600, correct? At the end of every 6 months, it means that the PY value would be equal to 2, correct? All right, good. Now, interest is compounded, is 4.07% compounded semi-annual. So this CY is also equal to 2. Now, what else is there? Well, we have those values and we can get at N. Remember, another note about getting N is that we have to have the number of years. So this will go on for 22 years. She will collect, or Alexa will collect $3,600 for 22 years. Now, the interest rate, sorry, let's put up the interest here, up here. The interest rate is what? 4.07%. All right. Now, this is looking at what will happen in the future. This is what Alexa is planning for. That for 22 years, Alexa would like to receive $3,600 every 6 months. All right. And this is what the projected interest rate is supposedly will be. All right, now that is down here. Up here now is where contributions will be made. So how much money should Alexa have in her RRIF to receive payments of $3,600? So down here, what do we want to compute? Well, we would like to compute the present value, correct. All right, so Alexa has to have money, present value amount, to be able to sustain these payments for 22 years. All right, so that is what is happening. Okay, so we have these values and we can start. We can use the calculator, we can insert those values. Maybe we should put them over here first so we can see them. So that is 2, and so is CY is also 2, PY is 2, CY is 2. Let's put in the interest rate, it's 4.07. The present value is what needs to be computed because what is happening is that Alexa has to have enough money in here to be able to finance this payment of $3,600 every 6 months for 22 years. So this present value will be the goal that this registered retirement savings plan is moving towards, is to get a future value. All right, that is the same as this amount here. So two phases of life. One is the saving phase of life, and one is the receiving. All right, so payments now. Payments that would like to be received would be the 3,600 right up here. So that would be the number that would go in there now. That will eventually, the payment will empty the account, and the future value down here will eventually be zero. Right? So you want to compute the present value, but the future value will go down to zero. All right? So up here, you want to get future value. All right? And that future value will be this present value down here will be the amount that is going to come up here to become this future value here. So that is the goal, to get a certain amount of money up here, and that to finance what will happen in the RRIF. Okay, so the RRSP is the savings and the RRIF is the income, meaning receiving. All right, so let's have a look at that now. Okay, so let's get the calculator so we can do some calculations and see how it all works out. Now let's move this over here so maybe it won't get blocked there. Okay, so we know how to get the PY in there. So that the PY is 2, we press on 2 and we press enter. When we go down for CY is also 2, or we could still enter it and click on enter, and there we have CY is 2 and CY is also 2. Okay, so we can hit clear and then we come out of there. Now we are looking at the number of years because we want to calculate N. So if we use 22 years and then we go second N, it's entered, so N is 44. Right? IY is 4.07, so 4.07, and that is the value for IY. Now the present value is what needs to be computed, and the payment is 3,600. We could put that in as positive because Alexa will be receiving that. And 0 for the future value. And now we can compute the present value, and that turns out to be $103,996.27. Okay, if we round to 2 decimal places, so there we are. Right now, this number here, okay, if you like to put in the comma just to make it more readable, this number here is the goal for the registered retirement savings plan. All right, you are saving up down here to finance what is happening in the income fund. So the savings plan finances the income fund. Okay, after you saved it up, then you will start receiving it when retirement comes. All right, so we can go and fill in these boxes here. So this would be 2 and CY will also be 2. And we skip over, and the interest rate is still 4.07. How do we know? Well, it says that interest is 4.07 compounded semi-annually for both the RRSP and the RRIF. All right, now what is the present value here? Well, that present value is 0 because this part is the contribution part. Okay, we're working backwards because you're planning for the future. So you have to find out how much will be need to be contributed or contributed here to finance what is happening up here. So we'll put in here, the payment is what we need to compute. What payment will Alexa have to make at the end of every 6 months into her RSP so that there's enough money in her RRIF at the end of her retirement? So here we are, and this would be the amount that needs to be computed. All right, so we need to compute the payment. Okay, so now we can make this positive, this present value, and that will become the future value for the next phase. Or we could just go and enter this into the future value there. Now, PY and CY are the same. We can just go and check. So second IY, PY is 2 and CY is 2, and we get out of there. Now, this phase here in the savings is 28 years, all right? That's what it says. Alexa makes regular end-of-term deposits into her RRSP that will be converted into an RRIF 28 years from now. So the contributions will go for 28 years. So we use that 28 and we can then calculate N, which turns out to be 56. All right, so now that we have that done, the interest is 4.07 as it was before, but we can just recall IY and we see 4.07. Now the present value is 0 for this phase of the calculation, and we would like to calculate the payment. Now we did enter the future value, so we can just recall the future value, and it is pretty much rounded. If it's rounded 2 decimal places, then it would be a 27 instead of 2651. Now let's leave it like that, and we compute the payment. So the payment that has to be made every 6 months is $1,012.61, right? 1012.61. And if we submit that, hopefully all is well and all is correct. All right. So here's a question that is very practical. It goes through the planning phases. And so to attain this future value now down here, this present value, we can delete it if we wish. We can delete these markers here and say that the present value was equal to, what was it equal to? Well, 103,996.27. So that was for this part of the calculation. We had to get that number. All right. Now that number will become the number that goes up there. That is the goal of this, of the savings, is to accumulate that amount of money. Okay, and that occurs over 28 years, and the payments go in. Yeah, they go in semi-annually. So you have PY is 2, and so is PY. That is also 2. And then the goal of it was to amass this amount of money, $103,996.27. So to do that, the payment turns out to be, the payment, is right down here, which is this number. And so that is the amount of money that Alexa has to put in into the account every 6 months. So this is the answer right here. I will change this color up here to a different color because this is not the answer we're looking for, but it is important because that comes down from down here. Okay, so that is why this number here, down here, Okay, sorry. The number down there will go, the present value will come up here because that is what the amount that needs to be saved to finance 22 years, as it shows right here, 22 years of receiving $3,600 every 6 months. All right, so that is a bit of planning for the future. Okay, so that is number 3. Next question is starting now to introduce us to the beginning concept. Remember, if we look at the calculator previously, we would not see the word end. Okay, you wouldn't see the word end, but now you will begin to have a look at that. Shortly, I will show you. Is another part of what we're doing. And that is if we click on this second PMT, you will see end. End is the default mode. So to change that, we click on second, enter, and that gives us the begin mode, right? And we can come out of there. So these are now the new questions where deposits are being made at the beginning of the payment period, the beginning of every 6 months on account. Okay, and the interest rate is 2.92 compounded semi-annually. Answer the following questions and round all answers to 2 decimal places where necessary. So the first thing is this, to choose between begin or end. So we are in the begin mode, and you saw how that was accomplished over there. All right, so what is the present account balance? So 6 years ago, Kirsten began depositing $600 at the beginning of every 6 months into an account. That was 6 years ago. Now it's every 6 months, so PY is 2, and then we have the interest is compounded semi-annually. So CY will also be 2. Let's skip over N as we normally do, and the interest rate is 2.92. We see it right up here. Okay. Now the present value is what? Well, the present value 6 years ago, that is what you have to consider. All right. You want the value, the present account balance. So please be careful. Don't let present mislead you. You are indeed truly need to find the or compute the future value. We're looking from the perspective of 6 years ago. So 6 years ago, the present value was 0. Yes. Okay. And then you started. So you made payment of 600. Now we could put that in as negative, right? Okay. That is just fine. We'll put that in as negative. Okay. So there we are. And now we can do some calculations. So let's go now and go second IY. We have the begin up there. The PY is 2. If not, we can enter it, and CY will also be 2. So we can come out of there. And now how many years? Well, it's 6 years ago. So that is where we'll get the 6 from, and go second and N. And N is now 12. Okay, IY is 2.92, so there we go, 2.92. That's IY. Present value is 0. The payment is 600, and we put it in as negative, so 600 plus minus makes it negative, and then it is entered. All right, so we'd like to compute the future value. So we go with CPT and we click on the future value, and there we have it. $7,600. $921.23. We round it to 2 decimal places. All right, now this is what happens. Kirsten stops making deposits immediately. How much will be in the account in 5.5 years from now if interest remains the same, 2.92 compounded semi-annually? Okay, so the deposits have stopped. What does that mean? That means that the payment is now zero. All right. Now, how much money is in the account? It is this future value right here that will be deposited into this present value or entered as the present value. CY remains the same, 2, and CY is 2 because now we are doing compound interest. You will notice the 0 right there. All right, the interest rate remains the same also, so 2.92. All right, so what are we computing? Well, we are computing the future value, right? How much will be in the account in 5.5 years from now? Okay, so we are going to compute the future value. Okay, good. So let's go. We have this future value here from the first calculation when contributions of $600 were being made semi-annually or twice per year. So that value we will enter into the present value, right, for this second part of the calculation. Okay, so let's go back and check just to be sure that PY is 2 and CY is 2. All right, now we come out of there. Now, we know that it is now going to be for 5.5 years. So 5.5 is indeed 5.5, right? Or if you want to be sure, you divide 1 by 2, you get 1/2, and then we add 5, so it's 5.5. Then we go second, n, and n turns out to be 11. Interest rate remains the same, 2.92, so we can recall the IY, and it is correct. The present value should be what this future value is up there. If we recall that value, it is 7921.23 or 229142. Okay, payment is now 0 because the payments have stopped. Okay, she stops making payments immediately. So 0 goes in for the payment. And then we compute the future value. And the future value turns out to be 9,290.43. Okay, so there we are. And we click submit and everything is correct. So that is the first part of using the begin mode. Now, let's note this important fact. The begin mode, I didn't change it when I did this part here for the compound interest. Now, this is the answer. We have the answer right here, and the answer is correct. Now, I could have changed it to the end mode. There we go. Second PMC, second enter, and we're in the end mode. If I come out of there and I compute the future value, I see I get the same value. Now that is so you did not have to go to end, although it is good practice, you can say. And why did it work? Well, it worked because the payment is 0 for the second calculation. If they begin and end, the effect comes about when a payment is involved. And as you can see at the very top there, I can go back and do these calculations. Let's go back and just show it to you that we will get a wrong answer. So PY is 2, CY is 2. All right, the number of years was 6 years. All right, so let's go back. So 6, second, n, and there's the 12 right there. 2.92, we have it already in the interest, correct? The present value is 0, so we put 0 in there for the present value. Payment is 600, and it's negative. And now if I compute the future value, I get the wrong answer. 7807.24, and that is incorrect. So this is the correct answer. Now, if I go and now change the calculator, so second shows up there. I click on TMT, I see it end. Now I go and fix that by clicking on second and then enter. Now I have begin. Now if I come out of there and now I compute the future value, I get the correct answer, which is this number right here, 7921.23. So just for you to understand that it's not affected, this part, the compound interest, because the payment is 0. Just in the event that you are wondering that you left the calculator in begin mode and you got the right answer, yes, it should work out. But if contributions were continuing to be made, let's say this changed to maybe 400 instead, then an error you will get the wrong answer in there. All right, so that will be it for today. And we will end there and continue next time.